Welcome back to my YouTube channel, and in this video we are covering Form 3 Chapter 1 Indices, and personally it's one of my favorite topics in mathematics, and you'll see why. So without any further ado, let's begin. I have separated this topic into two parts. Well, the first part I'm mainly going to focus on understanding it, like what is index and how we have to approach it. And then in the second video, I will be going in depth about the laws that you have to remember and how to solve problems. So indices. Before going in depth, you have to understand what is an index notation. Given a to the power of n. This is an example of an index notation. This a stands for base, and this n stands for index, or we may have also know it by the name of power. Usually we say this as a to the power of n. What does this mean? Oh, by the way, this index can also be called as an exponent. So what is the meaning of it? So that for you to understand the meaning, let me give you an example. Let's use a simple number. 5 square. 5 to the power of 2. So from this example is directly derived from the a to the power of n I've written above. It's the same thing. So in this instance, 5 is a and 2 is n. So what does 5 to the power of 2 mean? It just means that 5 times 5. This 2 represents the number of times 5 multiplies by itself. So there are 2 times here. So 5 times 5 is 25. So is 5 times 2, which is also 5 square, which is also 25. So essentially, a here represents what number is being multiplied, and n represents how many times it is being multiplied. So I will give you an example here. For instance, we have 4 times 4 times 4. So if you were to write this in an index notation form, what would it be? So the base is the number which is being multiplied, so it is 4. And the index or the exponent or the power is how many times it's multiplied. So it's 3. So 4 to the power of 3. Or we also call it as 4 cubed. That's it. It's as simple as that. Let me give you one more example. Negative 2 times negative 2 times negative 2 times negative 2. So to write this particular expression in the form of index notation, what would it be? So same thing. The number which is being multiplied is the base, so the answer would be negative 2. Then the exponent, the index or the power is how many times it is being multiplied. So we have 1, 2, 3 and 4. So it's safe to say that this whole thing is equivalent to negative 2 to the power of 4. Do you see how simple is that? So with this we can conclude that a to the power of n is actually a times a times a times dot 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 times a, where the number of the numbers of a's that are being multiplied is actually equivalent to n. So there are n number of a's that are being multiplied with each other. And there's a rule here that a should not be 0, but that is kind of counterintuitive, that if it is 0, the whole answer would be 0 and we will not get any new values by powering it. So that's that. Do you understand? I hope you understand. If you don't understand, try to watch the video. Try to watch this part one more time, so that you get a kind of a clear understanding of what's happening. And moving on, I will be showing you how to get the index notation of a particular number. I'll give you an example. For instance, I would like you to give me the index notation of the number 125 with the base of 5. I wonder, how do I do this? So here's a tip for you. Base 5. So from what we know from the previous derivation, we can say that the base multiplied by itself a few number of times, which is n times, will result in 125. So we have to know how many times 5 is being multiplied to get 125. I think I just repeated myself twice. So here, to get the answer, we just have to do repeated division. That's it. So 125 divided by 5. How much do we get? We get 25. Same thing, 20 divided by 5. We also have 5, 25. So we'll have 5 right here. And then one more time, 5, we get 1. As you can see, how many times do we have 5 here? 3 times. So it is safe to say that the answer is 125 is also 5 to the power of 3, where 5 is the base number, which is the number that's being multiplied, and 3 being the index or the exponent, which represents the number of times the base number is multiplied. So in this case, 5 is multiplied by itself 3 times. 5 times 5 times 5. So for good measure, I will give you one more example, and I would like you to try one by yourself. So we have, let's say, 36. Nah, that's too simple. Let's have what about 512 with the base of 8? Base 8. So same rule applies, just to repeat the division with the base number outside and the number you would like to find inside. So take a calculator, 512 divided by 8, you get the answer 64. And then moving on from that, 8, 8, 64. Move along, and then 881. So at this point, you can see that we get one already. So that means we have reached the end. So the base is obviously 8, and we have 8 multiplied by itself 3 times. So 8 to the power of 3, which is 8 cubed. And it's correct. If you type in 8 cubed in a calculator, you will get 512. Talking about how to type in a calculator, no worries, I will show you right after this. But before that, let's have you try one question by yourself. So the number is 64, and the base I would like you to find is in base 2. Keep it simple. You can pause the video now. I will be giving out the answer right now. So please pause the video if you would like to try it yourself. And I will show you the answer. 64 divided by 2, we get 32. Then 32 divided by 2, we get 16. Then 16 divided by 2, we get 8. Then 8 divided by 2, we get 4. And 4 divided by 2, we get 2. And 2 divided by 2, we get 1. I know it's quite a tedious process, it's a long one, but don't worry, bear with me and trust me, these are the easier parts of this topic. So the base is 2, and what's n? So we have 1, 2, 3, 4, 5, and 6. So we have 6 2's here. So 2 to the power of 6. And that's it. We have done it to the power of 6. I hope you got the right answer, and I'm sure you did. If you have any confusion, always rewind to watch the part that you don't understand. Try to watch it once or twice. If you still can't get it, then ask me questions in the comment section below or email me. Anything is fine. I'll be more than happy to help. So here, now that we're talking about just understanding how all of these work, all of the main concepts work, I would like to show you how to use calculator for this as well. So we are mainly using two calculators, Casio 570. 570 is the better one. 350 is pretty good, but 570 has more functions and it's more in use. So for Casio 570, we have two different models. One is in white and another one is in blue or gray. I'm not sure about the color. Sorry, I'm very bad with colors. Then there are more than that. There are other colors as well, but mainly there will be two symbols that represent this power. So for power in the classic one, which is the blue, I think it's blue. It's blue. So it's going to be in this form, in this shape, like an upside down V. So what you have to do is type in a number, for example 8, then right after that eight, and right after that put down this symbol. This means to the power of 2. So 8 to the power of 2, which is 8 times 8, and you should get 64. If you're using the other version, which is the fancier one, you'll have this button that shows x to the, pardon me, it will show a button where it is x to the power of some kind of white box here. So the same thing. So what you have to do is type in a number. So for example, the same example, we have 8, this x symbol to the power of, and then type in the number 2, and you should get the answer 64. That's it. And yep, that's all. This is all you have to know to have the main understanding of how everything works in indices. Just remember, a to the power of n, a is the base, n is the index, the exponent. A is the base number, which is the number being multiplied, and n is how many times that base number is being multiplied. So for example, 8 cubed is 8 times 8 times 8, 3 times. So that's all for the understanding part. I will be back with part 2, where I go in depth on the law of indices and how to do the calculation. And trust me, it's going to be interesting, but you have to focus. So I hope you learned something from this video, and we'll see you in the next one. Bye bye.